Okay, I think the first thing to start off with is to see if this is working properly. So anybody that can hear me, just put up your hands, please, and make sure that everything is working audio-wise. Okay, looks good. Just want to make sure we have everybody that can hear me. Because sometimes if you log in with something other than Firefox or Chrome, you don't have audio and all sorts of stuff doesn't work properly. So if you can't hear me, then we got some issues to deal with. Okay, so I'm just going to post this out in the room. So you can put your hands down now. Let me just post this out. If both hands up, okay. Okay, so what I posted in the room was if you can't hear me, you have to use Firefox or Chrome. And if you use something like Microsoft Edge or Internet Explorer, as I used to call it, you're going to have some issues. Even Safari for the Mac won't work properly with Collaborate. So you do have to be aware of that. What are you using right now? Chrome or Safari? Because it will kick you out. It will do all sorts of nasty stuff to you. The only two web browsers that will work properly are Chrome and Firefox. Anything else, you're going to have to get rid of and set up properly, okay? So, yeah, so you can put your hands down now. What we're going to do is we're going to take a look at Microsoft Edge. Not a good choice. It will kick you out eventually, and your audio won't work if you properly and all that kind of stuff. That was what happened over the summer. I can't guarantee that it's working now or not working now, but I know that Chrome and Firefox are the two reliable ones that you should be using, okay? So let's take a look at a couple of things. I'm just going to switch our screen over to some stuff that was asked earlier. Let's just share another screen here. So I'm just going to go over here and take a look at content, which is this. Okay, so one of the things that you have to do, and you'll find this in the announcements. So let me just scroll up here. So you've got all these announcements and stuff coming in. This is the important one that I need you to do as soon as possible, hopefully before the end of next week, because you should have your Freedom K64 board, and you do have to give me your first name, last name, student ID, and the serial number that's on the bottom of the board. And it usually starts with a TR or something, and also include your lab section. Because what it says is you have to be aware of some things. So let's take a look. So the required supplies, you should have those, and it shows the video and where to get them. And you should watch this introduction and overview of MCO455. Now let's see, somebody posted some stuff. Let's see what you got. In-person elements. No, this is all online, including the hardware issue, okay? So like when you start dealing with stuff, you're going to be working at home. There's lots of videos and so on to show you how to do stuff. And I'm going to point you at a lot of this stuff today. Now, the unfortunate thing is, and let me see if I can switch over to the right screen here. There we go. Okay, let's see. Yeah, you're all seeing that. Good. So one of the things you're going to see is that the MCO455 DF starts today, and it's at 3:20, which is now. But the D group started before this, and they're going to be a little bit disadvantaged over the time. But here's what we're going to do today to help them out. The stuff that they covered yesterday, we're going to cover in the E and F sections, which is here's F and here's E. We're going to cover that in these two sections later. What we're going to do is start sort of halfway through and go over some basic things that you're going to need to know to get most of Lab 1 done. Now let me see which one is Lab 1. Nope, that's not it. Here we go. So Lab 1 has to do about number conversions, okay? And a lot of the stuff, and we'll be dealing with in your lab class for the E and the F group, how to do binary to octal, binary to hex, all this kind of stuff. And we'll talk about questions 1, 2, 3, which is adding and subtracting. And we may do a little bit of that today if there's time, and binary and hex, and something called NZVC. So we'll definitely be doing a little bit of this. And we'll worry about in next lab for E and F, we'll worry about question 5 here. So what we're going to do is we're going to sort of focus on the difference between signed and unsigned numbers. We're going to be taking a look at unsigned and signed shorts here. We're also going to be looking at ANDing and ORing and exclusive ORing. So those are the kinds of things that we're going to sort of work on today. And the other stuff, the first 5 questions, or some of the first 5 questions for the E and F, we're going to be working on in your lab class, so that hopefully by next week you'll have everything ready to go. So let's take a look at the addendum, and this is the most important document that you've got. And what you're going to see here, let's see if I can scroll that down a bit. There we go. Okay. So week 1, we're going to be doing some stuff. I'm going to leave some of this stuff for you to look at. So there's a course overview. So you should look at that. There's a preface section here. And the number conversions we're going to be dealing with in the lab, as well as ASCII and alternate characters. Practice quizzes. So let's take a look over here. Everything is pretty much set up in a very simple manner. So right now, let's take a look. Course textbook is here, and you'll find course textbook is available in your lab and theory sections both. And you just click on this. This is free. This doesn't cost anything. It's here, so you can actually go through it and start reading up on things like the introductory chapter. Now there's preface, and there's going to be some questions on the preface. The introductory section here goes through assembly language. What is it? What is C, CPU, and so on. A lot of theory kind of stuff, but there's also things in here like hex additions, hex subtractions, NZVC, and so forth that have to do with lab 1. Now, there's also chapter 2 and so on. So all the information is here. This is the textbook. As I said, it is free, not a problem. Let's go back and take a look here. So also what we have here is we have video lectures. So this is our week 1 video lectures here, and there's a few of them here. So the course overview, there's going to be a quiz here under practice quizzes for course overview. There's going to be a practice quiz in here for preface and number conversions. Now we're going to focus pretty much on number conversions and ASCII characters for this week. And let's take a look again at where the timing is. Let's see, are we here? This one, we'll get the right one eventually. Where did my addendum go? It's on here one of these places. If not, I'll just pull it up again. So let's do that. So this is the most important document that we've got. And there's 2 versions here, a Word format and a PDF with no clickable links. Let's take a look at that. So to reiterate, let's take a look. This is week 1. Let's bring that down a little bit. So we're going to be the course overview and the preface. You can look at the video lectures for that and do the practice quizzes for that yourself on your own time. So that's a quick introduction. It gives you some stuff, and the questions that are on the practice quizzes will probably show up on the chapter quizzes. The chapter quizzes will show up in the term test, and the term test will show up on the final exam. So all of this stuff is highly integrated. Now we have a question out there. What is the question? Mr. Kim, can you turn on your mic? Oh, I've shut off the mics. Just a minute. Let me see if I can turn on mics now that you guys are here. I like to leave the mics off when we first start, so I'm going to put down share audio. So if you want to talk, please turn on your mic, and when you're finished, shut it off. So if anybody has a question, just post it in the room or say something. Is everybody's okay? All right, so if you post a chat message in the room, that's probably the best thing. If you go to chat and go to everyone, then everybody will see the question. I'll look at it and I can respond, okay? So that's probably the best thing. The reason we're not putting video out there is because Blackboard Collaborate uses a lot of bandwidth. And if we were to allow everybody to show video and all this kind of stuff, the whole system would crash. I've seen this happen in WebEx and a number of other things. So for the most part, chat is probably the easiest way to deal with things. And when you post something in the chat bubble at the bottom here, I'll see it, I'll be able to respond to it and come back, okay? Now, for those people that are getting kicked out and leaving the room and coming back in, again, please use Firefox and Chrome. Those are the 2 things that will work. Okay, now, Mr. Kim, do you have, Kim rather, do you have any questions? If you do, you can post it out in the room, or you can lower your hand. Mr. Ahmad Mustafa, you got a question, please?
I'm just wondering, will every lecture be streamed?
Yes. Every lesson will be streamed, and it'll also be shared. It'll be put in video format. In this particular one, because I've set so I can download it, I can actually edit this one and put it on YouTube and post a link to it later. But it will be available under, like when you go and take a look under Blackboard Collaborate, if you know how to get to the videos, this video will be there. So if anybody has come late or they can't quite make the lecture, it's going to be here. Plus, there's a lot of videos already on the system where you can look at them at any time. And these are all YouTube videos, except for the one that Blackboard Collaborate puts in. And the beauty of that is these YouTube videos, you can actually closed caption them in any one of 104 languages. I'm still waiting for them to do Klingon, but you know, who knows? So again, let's take a look. So the things that you're going to be responsible for yourselves is course overview. Please do the video lecture for course overview, then do the practice quiz for that. The preface, same thing here. I'm going to leave that up to you guys to do the video lecture and the practice quiz for that. As far as the other stuff, we're going to be covering it today, and in your theory class is today and on your EF, because the D guys have already had this. Lab 1 is on number conversions, and what we have to do in there, and we're going to spend part of our time today, or a big part of our time, trying to do most of Lab 1, because Lab 1 is going to be done in this theory class. It's also going to be done in the EF group later this week. The D guys, they're going to be working next week on, as you can see here, a Lab 1 quiz. Now, the Lab 1 quiz is the first real evaluation that you're going to do. These practice quizzes that are there that go with the video lectures, that go with the textbook, the practice quizzes don't count for anything other than to get you up to speed for the marks that are going to be on your lab quizzes, or sorry, on your practice or chapter quizzes. Here we are. Week 3, you're going to have a Chapter 1 quiz. This is theory. Next week, you're going to have this in the lab, and we're going to talk more about that as we go through. So for the first week, it's a lot of learning. The second week, you're going to be doing a Lab 1 quiz, and I'll talk a little bit more about what that is. And all of the things about when they're going to happen, I'm going to try and hold as close as I can to this schedule. So everything where it says 2%, 2%, 2%, those are quizzes and so forth. You'll notice at 6, we have term test 1 worth 15%, lab test 1 worth 15%, so there's 30% of your mark coming right there. For each lab quiz, that I will have to let you know how much time you're going to have for each lab quiz. Typically, the lab quizzes shouldn't take that long. Some of them are going to be long, some of them are not going to be that long. If necessary, I can give you both periods, but I don't think there's going to be a lot that need that. But even if I give you both periods, let's just take a look back here. For instance, on lab quiz 1 here, okay, if you get done early, then you have to prepare for the following week, where it says preparing for lab 2 here. It says create an MBED account, installing a serial driver, configuring PuTTY. If I give you 2 periods to do lab quiz 1, then if you're done early, which you should be, then you can do all this stuff, because the following week there's a lot of setup you have to do before lab 2. And lab 2 is a quiz right away where you're going to have to have created all this stuff. You're going to be fixing stuff. I'll go through a little bit of that as we go through, probably in your lab class if you haven't already seen this for the D group. The D group should have seen this. I've done a quick demo. But again, the important stuff is lab. Let's go back here. Sorry, I jumped ahead a little too quick. So week 6 has your big evaluation stuff. You have 2 periods to do term test 1, 2 periods to do lab test 1, because that's 30% of your mark. And down here, there's the other evaluations and so forth. And you'll find that the final exam is 20. You've got a lab test and term test of 30. 50% is coming in the last couple of weeks of the class. Now, some of the more important things to note about this course, and a lot of these courses in this thing are set up the same way, you must pass both the lab and the theory to pass the course. Now you'll notice here that the lab is only 40% of your mark, but if you fail that, you fail the whole course. If you fail the theory, you fail the course. If you fail both, well, hey, you failed. And the thing that it says here is you must take a picture of the bottom of your Freedom K64 and before you can do labs 2 to 8, or lab test 1 or 2 and get any credit for that, because if you don't, then you will not get credit for that, because we want to make sure that you have your hardware available. And it's not difficult to set that up, and I'll be managing that for all 9 lab sections. There's about 200 people or more maybe doing the labs, and I've got a big chunk of those. So the bottom line is we want to make sure that you've got the equipment and not sort of trying to fake it, because the stuff that you've got, and this is important, when you have the Freedom K64, it takes only about 2 days to ship it to your house. So there's no excuse for anybody not having it. The seed stuff that's down here will take considerably longer. Now, some people have run into problems with this, and some of the problems have been that they tried to do DHL. Do not use DHL for shipping of the seed stuff, okay? Use the cheapest one there, even though it may say 20 days, because let's take a look at where you need this stuff. Notice here when we go through the labs, you know, it's got here Lab 1 quiz and all this kind of stuff. Everything down to including Lab 4 here has to do with stuff that's just on the Freedom K64. The RGB LEDs are there, the push buttons are there, and all that kind of stuff. So for the first half, you don't really need to have any of that seed stuff in your possession. But starting the first week back, you're going to be doing temperature sensor. You're going to be doing, you know, A to Ds, all this kind of stuff, and temperature sensor, pod, all this kind of stuff, Grove LCD. So one of the reasons for making it cheap for shipping is because as long as it comes within 7 more weeks, you're okay. Okay, and that's a fair amount of time, right? So that's why you use the cheapest shipping you can for the Grove stuff that's here. So as I said, we're going to be pretty much following this very rigorously in terms of trying to make sure that everybody knows when your evaluations are going to be. Oh, DHL already done, because if you do DHL, it's going to cost you a lot. It might show up fast, but it also gives you this VAR, value-added stuff and so on. So you want to make sure you do it cheap. That's why if you had to watch the getting started video or whatever I called it, you would have seen not to do that. You would have seen that, yeah, why don't you use, you know, the cheapest? And that's the reason why. Anyway, not risking it. Yeah, it's nice to play it cool. You spend some extra bucks and a little less beer money. That's all good. But anyway, yeah, hopefully at some point we'll get back to the point in time where, you know, getting a case of Corona means going to the beer store and not to the hospital. Let's hope we get there soon. But the second wave, who knows what's going to happen there. Anyway, enough of that. So let's take a look and see some of the other stuff that we've got here. Let me just flip back my screen. I got so many screens open here at the same time. So this is important stuff as far as having your equipment ready to go. And as I said at the start, if you take a look at announcements here, what I need here and at the bottom is to have those 2 pictures. Have a picture of your student ID card with your face on it showing, and the bottom of your board. And typically for the Freedom K64 serial number here, it's going to start TR or something like that. So that's, just make sure you write this in. So in your email that you send, fill in your name, first name, last name. You can just put a line in and say my first name, your last name, your student ID, and the TR number. Type it in, because I'm making another file of all this stuff, where the file will have all this for all 200 students, to make sure that anybody that has this will definitely get credit for lab 2, 3, and 4, and so forth. Now, the first lab takes basically 2 weeks, so it's only at the end of the second week you have to need the Freedom K64. And as I said, it only takes 2 days to ship, and we want to make sure you have it there, and we will not be giving you credit until for any labs beyond lab 1 unless you do have it. Okay, so let's see what else we got in here. So let's take a look at lab 1 again. So as I said, this is what you have to fill in. Now, one of the things you're going to do is, and this, I've tried to make this as easy as possible. These are clickable links. So you can click on this and it launches a YouTube video on how to go from binary to octal. You click on this and it says here to go binary to hex. Now the thing to remember when you're doing this, and I'll just mention this quickly because you're going to be doing it in your E and F later this week, that the stuff that's in bold letters here is correct. Are these 2 conversions correct, yes or no? And circle which ones are incorrect. And same thing here, octal, the stuff in bold here is correct. So you just want to see, are these the right conversions? And number 3, the hex here is correct. Are these the right conversions here? And you're going to have to write in from the ASCII chart what this message says, and then you're going to have to write back here what the hex characters are for this particular message, where this is a space, and a space here. So we'll be dealing with that a little later. This is going to be a fairly big part, and the people in the D group actually have done the adding and subtracting. We're going to do a little bit of that a little bit later, hopefully today, just to reinforce that. Let's see what we've got going on here. What do you mean in n equals 1, for example? We'll be looking at that, okay? And we're going to be talking about that when we look at the difference between unsigned char and signed char, something you did in PRG2, right? And unfortunately, what they've done now, which is kind of nasty, is they've slipped that in. I remember when I first started teaching in 1978, every student at Loyalist College, where I was at that time, had 33 hours on their timetable in a 16-week semester, and the provincial government was funding us at 9-0. That's it, 90% funding. Now we're down to about 20%, and instead of having 16-week semesters, right now we've got 12 because of COVID. So the students are, you guys are paying more and getting a lot less. That's why I've tried to make this as interactive as I can. So you don't have to be bored with me the whole time. You can be bored watching my videos, okay? So anyway, we're going to have to know how to do binary and subtraction. And again, 8-bit unsigned conversions. We'll deal with that in the E and F group, but we will look a little bit at this adding and subtracting later. But we'll see that we have something called 8-bit signed conversions. What do we got here? Well, let's just say that I'm trying to give you your money's worth, Ahmed, okay? The bottom line is when you had 33 hours in a 16-week semester, you were getting your money's worth because the provincial government was sharing out 90%. Now they're sharing out 20%, so, you know, it's tougher and tougher. And it's not because you have less to learn, guys. There's a lot more technology out there, and we want to get you as well prepared as we can for the real world. So, again, let's take a look here. So there's 8-bit signed conversions. And up here, there are 8-bit unsigned conversions. And what really that means, let's just put out a thing here. I'll give you a question. How many bits is a char variable? Is it 16 bits, 8 bits, 32 bits, 64 bits? How much is a char? Yes, you guys have got it. 8 bits, that's it. Now, here's a better question. Okay, you can stop now. You got it. Okay, how big is an integer? How many bits is an integer? And the answer is it's not fixed. It is not fixed. Remember when you guys did PRG and you were doing Windows, and you could select either Windows 32 or Windows 64? That was the size of your integer, because whatever your data bus size was that you selected as, say, Windows 32, then your integers were 32. You use Windows 64, then your integers were 64. So your data types are, the only fixed ones are short, which is 16 bits, long, which is 32 bits, char, which is 8 bits, long, which is 64 bits, but integer is not a fixed variable length, okay? So it depends on the microcontroller that you're using. Anyway, enough of that. Let's get back to here. So there's unsigned char, which is unsigned 8 bits. That's why these are all 8-bit numbers here. And there's also 8-bit signed. And we want to take a look at what the difference is of those. So what I'm going to do now is I'm going to switch over to my iPad. Hopefully this will work. Technology, sometimes Murphy comes to kick you where it hurts, and I get kicked a lot. So let's take a look here. There we are. So this was a drawing I sort of threw up in a hurry while I was eating my lunch here, so I do apologize for that. So there's 2 things, and I just want to sort of, before we get started at this, let's take a look at a C program. And it's got integer main void, A equals 0x7f, and 0x means hex, if you don't know this, and B equals 0x80. And it says if A is less than B, do this, else do that. Now is 7f less than 80? Let's just see a show of hands. How many think that 7F is less than 80? Nobody's putting up their hand yet. How many people think that 7F is not less than 80? See? Yeah, okay. Is 7F less than 80 or 7F greater than 80? Well, come on. There we go. Here's the thing. Okay, thank you. So here's what we're going to see is that it depends, guys. It really depends on whether you're talking about unsigned char or signed char, isn't it? So when you take a look at unsigned char, 7F is definitely less than 80, isn't it? But if you take a look at signed char, 7F is the biggest signed value and 80 is the smallest. So it really depends on what you've done. So let's take a look here. So what is the part that's missing? Let's put that in red. To be complete with this, it depends on whether you say, if you say char, whoops, come on, there we go. Char A and B, right? But what do you have to be here to say that it's one or the other? Because if you just say char A and B, and this is something you have to be very careful with when you're programming, because if you don't specify signed or unsigned, it's going to pick one, the compiler is going to pick one. And if you don't specify signed or unsigned, strangely enough, most compilers will pick signed char or signed short or signed long. So that's what it's going to do. And you think, well, char, I didn't put anything there. It should be unsigned. No, that is not the case. So if I happen to say the word unsigned here, then what I've done is I've chosen this up here, and I've changed my to unsigned line here, and 7F is definitely less than 80. So in this case, it's going to do this. If I change the word unsigned to be signed, it's going to do that. So there's two different number systems here that are completely different in terms of how they're interpreted. Now I know, for instance, in PRG2, a lot of this stuff now is glossed over because they have so much less time to cover it. Instead of 16 weeks, we're down to 12. And, you know, it's just trying to pack all that stuff in and get you guys to understand this. So we have to sort of get an idea of what this means here. So if we take a look here, we have something called the N bit. And the N bit is really the most significant bit of your value. And so if you take a look at these numbers, I'm going to try and write them in here. So 0 is 0, 0, 0, 0, 0, 0, 0, 0. This is 7F is 0, 1, 1, 1, 1, 1, 1, 1. So all the numbers here have the most significant bit, which is our N bit, as 0. Now all the numbers from here start with a 1. So 1 with a bunch of zeros here, all the way to 1 with a whole bunch of 1s. These are n equals 1 because the most significant digit, and that's what the N bit is, the N bit is the most significant digit. Now for unsigned char, whether n is 0, it's positive, n is 1. It is, whoops, that is wrong. I put something in there incorrect. I do apologize. Let me change that now. So you're going to find that whether n is 0, or the most significant bit of your value is 0, or if the most significant bit of your value is 1, they're all positive numbers, okay? And one of the things for the E and F group that they're going to see later when we do this in your thing is that if we want to convert 7F to decimal, it's going to be 7 times 16 plus 15, and that's going to give us 127. To go back the other way, we're going to divide 16 into 127, and we're going to get 7 with 15 remainder. Whoops, better make that a 7 here. A 7 with 15 remainder, which is 7F. So we'll deal with those aspects in your E and F lab, but I just wanted you to see that when we take a look at our unsigned and signed char, just making a definition between signed and unsigned is a big difference in terms of how these numbers get interpreted. Now, some of the things that you should be asking yourself is, well, why do we have two different number systems? Why would we need two different number systems? And the answer is quite simple. The answer is because microcontrollers, which are single chip computers that you're going to read about and take a look at in the videos and answer those lab questions, or sorry, the practice quiz questions, what you're going to find is that they deal with voltages. So if you have, well, let me change this to blue so you can see a little bit, or maybe green. So in this case here, and again, this is going to all be on video, so don't worry about it. The video is being recorded. So this would represent, say, 0 volts, 5 volts, plus 10 volts. And in this case, it would make sense to use an unsigned number line to represent positive voltages when you digitize something. But instead of having a single-sided supply, and you've seen this in your earlier courses in ELF or whatever they're called now, I don't know, they've changed the name so many times, this would be minus 5 volts, 0 volts, and plus 5 volts where you have a split supply, okay? And this is even in digital, right? It doesn't have to be AC, as Inya said. So the bottom line is you have, when you want to digitize, and this is something called, we're going to be looking at later, A to D, analog to digital conversion, is when the numbers or a voltage gets taken and broken into digits. So for instance, minus 5 volts for sine would be 80, plus 5 for sine would be 7F, but 10 volts for an unsigned would be an FF, and that's how it converts a number into some digits. Yeah, electronic sine waves, all that kind of good stuff. Okay, so this is the kind of stuff that we're talking about here. Now, let me see if I can clean this up a little bit and get rid of some of the stuff I don't need here. And so when we start doing additions and subtractions, and let's take a look at doing that. Let me see if I can put in the FF again properly here. So let's take a look at doing some addition. So as I said at the start, we want to do that because this is something that, even though the other guys have saw it in the D group, you know, they're not very good at it yet, and you guys are going to have to get a little bit of practice at this also in your E and F section later this week. So here's the deal. When you take a look at doing additions, and let's take a look at doing some simple ones here. Let's do this in green so you can see a little different. So for instance, if I say FF plus 1, that means I start here with FF, I have $255. Now the way this works is you take 15 and you add 1, and that gives you 16. So 15 plus 1 is 16 base 10, which when you work it out is 10 base 16. The 0 goes here, and the 1 goes to the next column, so 15 plus 1 is 16. That's going to give you 0, 0. You do not send labs. We'll talk about that now that we got most of the people here. You're going to be doing a lab quiz, which is multiple choice and true false, okay? So the labs aren't going to be submitted. What you're going to do is you're going to take the labs, print them out, figure out everything that's wrong, circle the things that are wrong, and figure out all the stuff in the lab this week. And next week in the lab class, you're going to have a lab quiz. And the lab quiz is going to say, well, are these the ones you circled? Or are these the ones you circled, like an A, B, C, D? And you're going to have to make sure you've got the right, and say, is this right? Are these the wrong answers? Are these the wrong answers? Are these, or none of these? And unless you filled in the lab 1 sheet, and you know what the answer should be, you have no way of answering that multiple guess questions, okay? Yeah, I said multiple guess, okay? Anyway, so in this case, we've got FF plus 1 is 0, which means I started with $255. Somebody gives me another $1, and I got $0. That doesn't make a lot of sense, does it? And the reason for that, if we said something like A equals 0x FF, and we said B equals 0x01, and we said C equals A plus B, what's going to be in C? What's going to be in C is 0, 0, because it can only handle 8 bits of information. The extra bit, which is what we call the carry bit here, is lost. Okay, that's our carry bit there. So this carry bit is lost because you added 2 8-bit numbers and you got 9 bits. You can only represent 8 bits inside a char variable. So this is something called, when you have a carry or C equals 1 means that you have an unsigned overflow. And what that means is you cannot represent the result properly on the unsigned line. It can't be represented properly. Does that make sense? So, and if we take a look, let's take a look now. You guys probably won't know how to do this, but I'll do this myself over here. Let's clear this out. And again, we can go through some of these adding and subtracting things a little later in more detail if you need. Let's do this again. Let's do this one in blue up here. So if you did something like 0.3 subtract 0.5. Now, I'll show you how to do this really simply, and we can go over this a little later. The people in the D group know this, and you guys are going to be drilled on this on the E and F group later this week, so don't worry too much about it. But the concept is here is that when you're subtracting, this 5 is bigger than this 3, so we have to borrow from this 0, but the 0 has no money, so what we do is we set the carry, and in this case when we're subtracting, it's called a borrow. And it's like I'm borrowing from the bank, now I'm using it. So what you owe and what you use balance. I don't know whether you've ever done double entry bookkeeping, it's a pain in the butt. So this 1 0 here doesn't represent 10 because this is base 16. This is 1 0, which is 16 minus 0. So that's what that is, okay? But what we're going to find is that now that this guy's at $16, this guy borrows from him, and that 16 that he has here, let's do it in red, this 16 becomes F, and this guy has a 1, 3. Now we'll talk about this EF later this week just to show you. So what this is 16 plus 3, 1, 3, base 16, decimal is 16 plus 3 is 19, minus 5, which is how much? 14, I think. So 14 is right, yes, 14, and 14 in hex is E, and F minus 0 is FE. Does that make any kind of sense? Whoops, I dropped my pen. So hopefully this makes some sort of sense. What this is really saying is I went 3 units this way, I went 5 units this way, and I went all the way around here to FE. That's where I end up. So whether you get carry equals 1 from like where you add 2 8-bit number, you get a 9th bit, or you subtract a larger number from a smaller number and have to borrow, in both cases that is referred to as an unsigned overflow. And if you think about it, anytime you subtract a larger number from a smaller number, what kind of number do you get? Usually a negative number. But since it's unsigned chart, you can't get negatives. So anytime the carry is by any kind of operation, that result is not valid as an unsigned value. Hopefully that's making a little bit of sense. Now there's some videos to talk about this on there, and it was the same sort of stuff, maybe a little differently. But it's really trying to say, when you do calculations, you're not always going to get results that make sense. Now, let me tell you something else. Even your calculator is not infallible when it comes to this stuff. If you take any number times 10 to the 99 and add it to itself, you're going to get an error. Why? Because your calculator has a limit on positive and negative infinity as well. So we can see that anytime the carry is set to 1, by adding or subtracting, it's an invalid result there when C equals 1. So let's write this up here again very quickly. And as I said, there's going to be a video so you can look at it and make your own notes later. So C equals 1 is an unsigned overflow. Whoops, I better make my print a little neater here. It's an unsigned overflow. And that's if you add to, and I'm going to call it n-bit because your number systems change, right? Like you got char, which is 8-bit. So if you add 2 8-bit numbers, that's n8. If you do short, that's 16. So n would be 16. If you add 2 16-bit numbers, you get a 17th bit. If you have long, that means it's 32 bits. And so if you add 2 32-bit numbers, you get a 33rd bit. So I'm trying to sort of write it in a generic way. If you add 2 n-bit numbers and get n plus 1 bits, that's an unsigned overflow. Or if subtract a larger number, a smaller one. So in both cases, and we've seen both of those in those examples, that's an unsigned overflow, and the result is not valid in that number system. And so if you got two 8-bit numbers, that means if I add two chars and I get, one extra bit, good. Anytime you subtract a larger number from a smaller number, that's a problem. Let's take a look at some of those calculations. Let's just move our screen up a little bit here. Well, let's take a look at those same calculations here. For instance, if I take a look at, let's see if I change my pen color to red here. If I take a look at doing FF plus 1 and getting 0, 0 plus a 1 here, this means that it's not valid up here, and we saw that. But take a look. FF plus 1 is 0. So something that was a problem as an unsigned addition is not a problem for sign, because FF is -1, -1 plus 1 is 0. Makes perfect sense. Let's take a look at a different one though. Let's take a look at 7F plus 1. That gives us 8, 0 and no carry. What does that mean? That means 7F up here plus 1 is 8, 0, and since it carries 0, it is a valid result. However, let's take a look at it as a signed number. 7F is 127. It's like I got all the money in the world, somebody gives me another dollar, and I'm $128 in the hole. This is called a signed overflow. 7F plus 8, 0 is fine unsigned because there's no carry, so it says that's perfect, it works, it fits within our unsigned bounds. But in this case, we have what kind of number? Let's just change my thing here to green. This is a negative number, and we, oops, sorry, no, wrong one, sorry. Let me get back here. Sorry, I was doing the wrong calculation. Let's go back here. So this is a positive number, and we're adding a positive number to it. And what kind of number did we get? 8, 0 is negative. Now, if you add two positive numbers together, you'd expect to get a positive, don't you? But if you add two positives and go past positive infinity, it wraps around to the negative side. And in this case, we have something called V equals 1, and V equals 1 means it's a signed overflow because we've overflowed our signed number system. Calculations that work in the unsigned may not work in signed, and vice versa. They may work in both, or they may not work in either, depending on the calculation. Let's take a look at another calculation. Let's start at the other end. Let me just get rid of some of our C program here. Boom, bang. So let's look at, and let's do some cleanup down here. Okay, so in this case, if we take, let's do this in blue, I guess. If we take 8, 0, and we add FF. Now this F plus 0 is F, that's not a big deal. Now F is 15. 15, so this is 15 plus 8 is 23, which is 16 plus 7. Now again, if you don't understand this, for those people in the E and F group, we will be going over this in detail again in your EF lab section this week. So, and let's take a look what that means graphically here. We started being the most in debt that we possibly be. We go another dollar in debt, and now we have all the money in the universe. I wish my accountant could work like that, but anyway, so this is a negative, and we're adding a negative, and we got a positive. So in this case, V equals 1, and V means signed overflow. It means that the number has overflowed the signed number's ability, number system's ability to actually represent a valid result. Now, one other thing that you'll see is notice we've got a 1 here. So this calculation, 8, 0 plus FF, is not only not valid as a signed value, it's also not valid as an unsigned value either. Okay. So let's take a look what a signed overflow means. Let's just move this down here and get rid of some of this stuff here and do some more writing. So basically, let's take a look what a signed overflow means. Signed overflow. A signed overflow means that V equals 1, and V equals 1 means yes. The 1 means yes, it's true that we have a signed overflow. And you get assigned overflow if you add two numbers of the same sign and get a result of opposite signs. And so what that means, if we want to draw it a little bit graphically here, a positive plus a positive giving a negative, V is 1. Also a negative plus negative giving a positive, V is 1. And so any calculations that do this cause a signed overflow. Okay. Now my question is, what happens if you add a positive plus a negative, or a negative plus a positive? Is it possible to get a signed overflow by doing that? Let's see a show of hands. How many think you can get a signed overflow by adding numbers of opposite sign? Okay, you're taking a chance. And how many think you cannot? Let's see a show of hands for those people. And the people that are in the majority have 1, and I'll show you why. Let's take a look at our number line again up here. And it doesn't matter what number you pick. If you pick 7F and you add a negative value, it's going to go away. It's like vectors. So let me just bring up my color again. So in the case here, let's see what color haven't I used. Let's try something, I don't know, purpley. So in this case here, if you add a positive, you're going in this direction. If you add a negative, you're going back in that direction. So what you're going to find is there's no numbers that you can put together that if you add a positive, even if you start with something like 0 and you add 8, 0, you're still here, right? If you start off with any number, and if you add numbers of opposite sign, they cancel out. So there's no way to add a positive to a negative, or a negative to a positive, and get V equals 1. So let's go back here for a second. So what this means is for these situations here, let me just point out again, this purple line around it here, V equals 0, which means no signed overflow for any numbers that are added that are of opposite sign. Okay, now it's going to take a little while, and as I said, let's just flip back here to another screen. Let me just share the right thing here with you now. So if we look back here, where are we? Share application screen. Where are we? lab1.pdf. Okay, so let's take a look at that and say allow. So when we take a look here, these calculations, and this is something that we didn't do the other day with even the D group. Let's take a look at these numbers, and let's just take a look at this one here. So this case, if we treat, now there's two ways to look at these numbers. You can look at these numbers as unsigned char, or you can look at them as signed char. But as unsigned numbers, here, all the decimal equivalents are positive. So that you could interpret this as a positive number. Even when this is a 1, this is still a positive number because these are unsigned char. However, when you take a look at here, there's a big difference, isn't there? When you have a most significant bit 1, the decimal equivalent is going to be negative, and we'll look at how to do that a little later. Notice here, though, this is negative, that's negative because the most significant bit's 1. This one's negative because the most significant bit's 1. In this case, this is 0, so this is not the right answer because these digits here, the most significant bits for signed, this is positive, negative, 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 so this cannot be negative. So this one, I'm giving you another bonus here. This is wrong. So when you take a look at one, make sure to circle this. It is incorrect. This, I'm not sure whether this is the right value, but at least it's negative, and this is negative, and this is negative, okay? So anything with the most significant bit 0 as a signed number has to be positive. Anything with a 1 here has to be negative. As far as the actual values, I'm not going to worry about that at this point. So let's take a look at doing some of these calculations back here, especially the ones in binary. Now, we're not going to do these, as I said, in the EF group. The D group should know how to do this roughly. But what we're going to see here is that this is a, if we treat this as a negative, and we're adding a negative, we got a negative. So that means V should be 0, which is true. I've got a negative plus a negative giving me a negative. So V equals 0 means not a signed overflow. The other thing is, let's take a look at some of these other bits. The most significant bit of the result is 1, and that's what the end bit is. Whatever the most significant bit of your result is, that's your end bit. Pretty simple, isn't it? Now, how you interpret it depends on whether you consider these signed or unsigned. As we saw earlier, it didn't matter whether n was 0 or n was 1. For unsigned, it's positive. But if you treat it as a signed number, this is a negative result. Okay. Now, the other thing is we got a bit called 0, z equals 0, and this is kind of cool. I don't know whether you remember back in programming, you always said return 0, didn't you? Now, there's 2 logic levels in C, and those 2 logic levels are 0 and not 0. Doesn't have to be 1, it can be a 5. It can be a negative 72. But the only real logic levels in C programming are 0 and not 0. So the thing is, if this is 0, this 0 means the result was not 0. 0 means the result is not 0. So if you look here, is this number here 0? No, because they're not all zeros. So this means it's not a 0 result. And the last thing is we added these 2 numbers together. Now, if you actually did the calculation, I think you would see, do you get a carry coming out of this? Well, that's something you're going to have to work on, and we'll do that in the E group or the F group later. And for the people in the D group, if you add these numbers in hex and then convert them back, I think you should see that there will be probably a carry here. Okay? So that's why I'm saying if you add 2 8-bit numbers and get a 9th bit, is this a 1? And you're going to have to do it to see, did I get an extra digit? And I think you can see this is F6. Chances are this should be a 1. Just a thought. All right, so that's the addition part, adding 2 positives and getting a negative. Now, the other thing is, what happens when you do subtraction? Subtraction is a little bit strange because you can still get a signed overflow by subtraction, but the rules are a little different, as we'll see. So let me just see if I can clear my board here and take you through a little bit of this. Or let me just go to a new page. Sorry about that. All right, come on, there we go. So go back to my iPad here for a second. Okay, so where you share my iPad. There we go. All right, so let's take a look at a review of subtraction for the people even in the D group that did this the other day. Because subtraction, even though it's easier than addition, takes a little bit of practice. So let's take a look at a number like, I don't know, binary 1 1 0 1 0 1 1 0. And let's subtract 1 1 1 0 1 1 0 1. Now, when you get good at this for the E and the F group, which is 2/3 of the class, and I do apologize for that, you can convert this to hex, and this value is going to be D6 minus ED. It's going to take a while to get that fast. Yeah, it took me, what, 30 odd years? But anyway, kidding. So when we do the subtraction, because this is the easiest way to do a subtraction for binary is to convert it to hex, and then you can say, okay, well, I've got 6 subtract D. Well, I can't do that directly because D is bigger than 6. I'm going to borrow 1 from this. I'm going to make D as 1 less, which is C, and that becomes a 1/6 base 16. Well, 1/6 base 16 is 16 plus 6, which is 22. And I subtract the D. When you look that up, that's 13. And this is going to give me 9, and that's what my answer is going to be here. That's the first half done. So I can actually write in 1 0 0 1. And again, you're going to learn how to do this for the E and F group later. And then you've got C minus E. Well, E is bigger than C, so again, we borrow 1. This becomes a 1C, which is 16 for the 1, and C is 12, so that becomes 28. And so we got 28 minus E, which is 14, which ends up being 14, which is E, so we just write down 1 1 1 0. Now again, you're going to learn how to do this in the EF group, and you can see that I've got a bit here. So this is what we've got here. Now the thing is, how do we figure out a number of things? First of all, for this calculation that we did here, obviously the n bit here is going to be 1 because it's always the most significant bit of the result. The z bit, is this all zeros for those 8 bits? And the answer is not 0. So that's fine. Then we have a c bit, and we said, well, did we have to borrow? Yes, we had to borrow, so that's a 1 bit. But now we have to look and take a look at what is this v bit going to be. Now, one of the things that you want to take a look at is saying that something like in decimal, when you did this in public school, 5 subtract 3 could be written as 5 subtract positive 3 or 5 plus negative 3. So you can always turn a subtraction into an addition by adding the opposite value. Now, without doing any calculations up at the top here, the top number that we've got here is negative because this guy here has a 1. And we're subtracting a negative. So a negative subtract a negative. So if we have some number subtract something, we can turn it into an addition by adding the opposite sign. So this becomes the same thing as a negative plus a positive. So a negative subtract a negative is the same thing as a negative plus a positive, because changing the subtraction to an addition, we have to change the other sign. And if you add a positive and a negative together, you're going to find that v is 0, only if you add numbers of the same sign. So in this case, there is our n, z, v, and c for this particular binary subtraction. And that's what I'm saying. You don't have to do it. You just have to rethink what is my subtraction of numbers as a addition by adding the opposite type number. So if we're subtracting a positive 3, it's like adding a negative 3. And by doing that, you can change it into an addition, where we apply the rule is if you're adding two numbers of the same sign and get an opposite sign, v is 1. Or if you're adding numbers of opposite sign, v is 0. It's pretty simple once you get to this point. But it's going to take a bit of practice, and there are some things out there that will help you. So let's go back and take a look at Lab 1. Hopefully this will make a little more sense now that you look at it. Let's go back to looking at Lab 1 here. Lab 2A, maybe that's not the right one. Nope. Let's go back here to, where did it go? Okay, let's do that anyway. So let's take a look. So in this case, you can see this is a positive subtract a negative. So a positive subtract a negative would be the same thing as a positive plus a positive, right? So a positive subtract a negative, same thing as a positive plus a positive. And what kind of number did we get? We got a positive number, therefore v should be 0. Okay, question. V is 0. Because if you change the subtraction, let me just switch back to my iPad here. Okay, let me just check back to my iPad here. Where did I put it? It's somewhere, there we go. Okay, so let's share back to here. So if you take a look at that, that is, let's look at that, that's a positive. Let me just take a look. That is a positive. Let me clean up my board here a little bit. I do apologize for the mess. So in this case, I think in binary you can see, let's do it in black so you can see it properly. This number starts with a 0, so that's a positive. This other number is subtracting something that starts with a 1, so that's a positive, subtract a negative. And if you change that into an addition, that's a positive. If you change this subtract to a plus, then you have to change the sign of the other thing. And the result we got had a 0 here, didn't it, as this thing. So it's a positive plus a positive giving a positive, and therefore v is going to be 0. Does that make sense? I hope so. Okay, it's going to take a little while to sort of get your head around this. Okay, so that's what I'm saying. Let's go back again and take a look at what we've got here. Okay, Manpreet, what's up? You can either use your mic or talk in the room. I see your hand up. You got a question? Manpreet Shahal? Okay, so my bad. Hey, I'm bad too. but I get paid for being bad, so it's all good. Anyway, so let's go back and take a look at, where are we here? Got to switch, got so many screens open here. So let me just go back here and take a look at our lab again. So when we take a look at our lab, you can see that this is a positive subtract a negative, which is the same thing as a positive plus a positive, giving a positive, so this is indeed correct. Let's look at this one. This is a negative. I'm getting a wire in the way here, sorry about that. This is a negative subtract a positive. A negative subtract a positive, so like a negative plus a negative, a negative plus a negative giving a positive. Is this correct? Yes, indeed it is. So this VBIT and this VBIT are correct. This is a negative plus a negative giving a negative, so this VBIT is correct. We're all good for all these, so the VBITs are not a problem in this one here. However, let's go back up here. And you're saying to yourself, oh my God, which one of these is positive, which one of these is negative, right? And when you start looking at that, you're going to say, well, how do I tell when it's a hex value? Is it positive or negative, and figure out all this stuff? Well, let's take a look. Let's take a look at switching over again to, if I can do this without killing myself too badly, let's switch back to my iPad and take a look. And let's switch over here so I can actually see what it was I was looking at. There we go. So we had something like, let's do it in black, AE plus CD. Now, there's a couple ways you can do this. You can write it into binary, which is 1, 0, 1, 0, which again, you guys in the E and F group are going to have to work on a little bit, plus 1, 1, 0, 0, 1, 1, 0, 1. This is the equivalent addition, and our answer, according to this, is 7B, if it is correct. So you have to say, is this the correct answer? So this is, if this is correct, you have to say, is my 7B correct first? Because if it is, then that's one thing. If it's wrong, then you have to sort of adjust things. So let's take a look. Let's do this in red again. So E and D. So this is 14 plus 13, which is 27 base 10. If we want to convert it back, it's 16 into 27 goes once, which is 1, 1. So our answer here becomes 1 for the first digit, and the remainder, 11, becomes our other digit, which is B. So what we do with the B is we write the B here, and we write the 1, and add that to the next column up here. Now this is showing you a little bit about what the guys in the D group did the other day. Well, let's take a look. First of all, we have to figure out, is this answer 7B, is it correct? Well, the B part's right. Now let's take a look at this. Is 12 for C, 10 for A, plus the 1 we carried over. So this becomes, what is that, 23 base 10, which when we divide it becomes 1, 7 base 16. So that becomes 7 with a carry. So the 7B is correct, so we're not going to change that. So let's take a look at what it means in terms of the VBIT and all this other stuff. Let's get rid of this business here. So the 7B is correct. Now, you're going to say to yourself, well, how do I know whether A is a positive or negative number as a signed number? And let's take a look at our signed line to sort of figure that out. So our signed line goes from 80 to FF, and it goes 00 to 7F. And in this case, all of these have n equal 1, which makes them negative. This has n equals 0, which makes them positive. Now for unsigned, all the numbers here from 00 to 7F, n is 0, which means they're positive. This one, n equals 1, and they're still positive from 80 to FF. So these have two different meanings, okay? So in this case, if any number from 0 to 7 as a hector, n is 0, as you can see here. Any number from 8 to F, n is 1. So when you're looking at these numbers in hex, you can just say, hey, okay, well, is this a positive or negative? What the heck is it? Well, is this 8 or bigger? and you say, yes, that is definitely bigger than 8, so that is a negative. Is C bigger or equal to 8? Yes, so that's a negative. Whoops, clear that out. That's a negative, and we're adding these together. What kind of number did we get? Well, 7 is in the range of 0 to 7, so that's a positive. And so a negative plus a negative giving a positive. What do you think the answer is here? And let's take a look. Let's go back to our little lab thing that we've got here and bring up lab 1 again since we worked that out. So there we go. Oh, hit the wrong button again. Hang on. Give me a second. There we go. Go back to lab 1. So we can see here that v equals 1 does make sense. So this number is 7b. Is it negative? No, it is positive because the most significant bit is a 1. So this is something you're going to circle. Does that make sense? I hope so. So that's what I'm saying. When you do this, a couple things that you have to do when you're working these out. Is this the right answer? First of all, is this the right answer here? I got the wrong screen, sorry. Is this the right answer? And if it is, are these the right bits for that? Is this the right answer? Whoops, is 82 the right answer? And if that, do these bits here make sense? So let's take a look at this one. 6 is a positive because it's in range 0 to 7. F is a negative, so this is a positive. Subtract a negative. A positive subtract a negative is the same thing as a positive plus a positive. And if this is right, that's a positive. So I wonder, So we've taken a look at some of these things in terms of that. And at any point, you can actually just click here and get a video, a YouTube video on how NZVC works. Okay, so, and let's just take a look at that briefly. I just wanted to show you something about these videos and boring myself with my own voice. Some of the things that you're going to find when you take a look at these videos, if you go to settings, it might do an auto 720. But and this is 720, which is fine, but sometimes just clicking on this will make it a little clearer. But you can also do something which is kind of cool. You can say subtitles off, and then you can say English auto-generated, and then you can basically click on this again and say auto-translate into any language you like out of 104. So for instance, I don't know, where are we here? NLP, yeah. JKL, NLP. There we go. So my wife happens to be Persian, so if she wanted to watch this, she could watch it in Persian like this. But at the same time, one of the things you might want to do is if you want to slow this down a little bit, you can go to settings and you change the playback speed from normal to something slower so you can actually read what's going on, shut off the sound, and see it in one of 104 languages, which I think is kind of cool. So anyway, that's the kind of thing you do with any of these YouTube videos. Some of them will show up at 480. And when you click on this, you can see that 1080p is available. So, you know, you might want to give it your highest resolution as you're watching this. Okay, so what did I kick into? So I'm just hoping you guys are seeing what I'm seeing here. Rats. I hit the wrong button there. So let's see, yeah, so you're still seeing that, which is good. So the YouTube videos are here to help you take a look at sign and unsign. I'm just giving you a quick intro here in the class to be able to do this. Now I do want to go through some of the other things that's on this lab. So let's go back and take a look at some of the other things you're going to have to deal with in the lab in the second part. So let's go back to lab 1. Where did it go? Did it disappear? Crap, I think so. Okay, let's take a look. Let's see if I can go back to here. Nope. Let's take a look at, okay, so right now we're in the DF section. Let's see, or what are you seeing? You're still seeing that. Okay, sorry about that. I went to the wrong screen here again. So let's take a look at that. You're seeing the same thing. Good, you're following what I'm doing. Okay, I just want to make sure. So let's go back and take a look at number conversions, and let's see where we're at so far. So at this point, you should be able to, at least if you know that these numbers are correct when you're doing the additions and subtractions, you should be able to figure out all of N, Z, V, and C for number 3 and number 4, okay? But here's the other thing that's going to fry your brains. How do we figure out these? How do we figure out doing the sign conversions and coming up with numbers that make sense, because that's going to be a little difficult as well. So let me switch you back to my iPad again and take a look at how you go about doing signed conversions. Let's go back to here. There we go. Okay, so again, and these are some of the things that you should think about. Okay, you're saying that good. So let me just go and so I can see what's going on. So for instance, if we come up with a number, I don't know. So let's draw our number line again just to remind ourselves. So sometimes you might have to do this 00, 7F, 80, FF, and these are unsigned numbers where it's 0, 1, 128, and 255. And as we saw, n is 0, n equals 1 here, these are positive, n equals 0 here, these are positive, but the signed numbers, half of them are positive and half of them are negative. So this is minus 128, minus 1. This is 00 to 7F, which is 0 to 127. So, and this again, n is 1, negative, n is 0, positive. So let's take a look at the differences between these. Just make sure you're seeing what I'm seeing. Good. So for unsigned numbers, so these are unsigned char. Let's do this in red. So for unsigned char, all numbers are, whoops, bring this down a little bit, there we go. All numbers are positive, and the n, which is our MSB, has no meaning. And we can see that by looking at our unsigned line here, that whether n is 0 or n is 1, they're happy positive numbers. However, in this case, for signed numbers, so this is for unsigned char, for signed char, and this also works for signed short and unsigned short, but in this case for signed numbers, half the numbers are positive, and that means that n equals 0, and half the numbers are negative with n equals 1, because this says not negative, this is saying yes, I am negative. Does that make sense? So, and this will be on the video, and the nice thing about video is you can do screen captures of anything on the video just to make yourself some short notes if you want. So I'm just going to get rid of some of this stuff now. So even though it's going away, it's still going to be on the video, don't worry about it. So let's take a look at doing some number conversions between signed and unsigned char. Just erasing my board here. Okay, so if we take a look, and let me just get rid of these n equals zeros because we saw those before. I just want to put some numbers in here. So my question is, if we have a number, let's get rid of these, n equals whatever, there we go. Get rid of that. So if we have a number, say, like A5 up here. A5, and for those people in ENF, you'll learn how to do this later. That's going to be 165 because that's 10 times 16 plus 5 is 165. And if you notice, this is 80 through FF here, and this is 8F through, or 80 through FF here, are not the same, are they? And if you take a look, this FF, which is 255 here, is offset to this FF, which is minus 1, by 2 to the 8, or 256 steps. It's gone it's like taking this whole section here and shifting it to the left 256 places, or 2 to the 8th places. So the thing is that if you want to say, okay, well, there's A5, whoops, there's A5 here, and A5 is 165, I wonder what this A5 is down here, because they're definitely not going to be the same. So the way to work it out is that you know that this A5 to this A5 is 256 difference. So you could just take 165 minus 256, and that would be your answer. Now, if you're working this out by hand, it's just as easy to say 256 minus 165, come up with minus 91 just by flipping the digits here. So that's how you would convert from a number that's in the range of 8 to F into one that makes sense in terms of this being a 1 here as a negative value minus 91. Now what happens though if you're given minus 91 and you say I want to know what that number is as a hex number? Let's see, we're getting problems here. How's my audio going? Okay. How about I go the other way? Well, if you think about it, I went from here to here by converting from hex to decimal. I subtracted 256 and I got here. To go back the other way, you'd start with minus 91 and add 256, right? And adding 256 is going to give you 165. And then you divide 16 into 165. And I want to show you something for those people even in the D group. 16 goes to 16 once. Bring down the 5. The answer isn't 1, 5. You have to divide twice. 16 goes into 5. Whoops. 16 go to 5 0 times. And so that gives us this value A as our first digit, and the other digit is A5, and we get it back again. So that's how you convert from here. But let me show you one other thing here. If let's do this in green. If I have something like 5A, 5A here is 80, that's 90 when you work it out. And so when you do this, 5A here is still 90 because these still have n equals 0. This is n equals 0. So the conversions are all the same as long as you're just going from 00 to 7F. It's only from 80 to FF that you have to do the subtract 256. So let's switch back to our lab here and see if this makes any sense as we switch back to our lab. And whoops, wrong thing. It's hard. I got so much stuff happening on my desk here. I do apologize. So let's go back to, there we go, lab 1. So when you take a look here, if minus 49, how do you do this? You're going to add 256 to this, divide by 16, and whatever you get here should be this value in hex. Now when this value is in hex, again, this is the right answer in bold. This is the right answer here. This is the right answer. So you have to figure out if all these other ones are correct. So again, there's some stuff on sign conversions, I think, in the lab. The other thing, so if you can work that out and figure it out, so there should be some stuff on signed and unsigned char. Well, we've gone through enough, I think, to sort of work this out. And if there's questions, and here's the thing. For every lab group and every theory group, I'm going to send a link out about a half hour early. And you can come in and ask questions about this stuff because it's very hard to set up any kind of common time to actually do open office hours. Let's take a look at this. Now, when you take a look at bit numbers, this is bit 0, not bit 1, but bit 0. This is bit 1, this is bit 2, bit 3, all the way up to bit 7. So this starts at 0. Like your arrays, this starts at 0 up to 7. So this is 0, so this is bit 7. I wonder where bit 6 is. Now, as a number that's signed, would this number be positive or negative? Well, what's the most significant bit? It would be, yes, negative. Excuse me. Now here's where it gets interesting. Trying to do these without a calculator. And I'll show you how to do these really quickly. I'm just going to switch again back over to my iPad here and do this really fast. And you can do this with a calculator, but I just thought I'd show you that you can sort of understand stuff a little better if you can sort of do it by hand as well. So let me just switch back and show you how you would do this, even though you probably wouldn't. You can use a calculator in most cases. But let's switch back to here. And, you know, when we do this is a real thing. So this was 60th, whoops, got to get my right pen out here. So if you have, I'm going to do, say, 65,000 instead of 60,000, just so you can do it yourself. You divide 16 into 65,000, that goes what? 4 16s, yeah, 24, 4, 5, 6. That's a 1, bring down to 0. 16 goes into that 0 times, bring down to 0. 16 goes into that 8, 7, 6, 6, I think. 6, 6 is not, and that's 96, that's 4, bring down to 0. 16 goes into 42, which is 32. So that would give us 8. So of the 4-digit number you're going to expect, this is this digit. Whoops, let's clean that up a little bit. Sorry about that. This 4th digit to the right is the last remainder, and that's going to be this 8. What you do is you take 16 into 4062, and this goes in twice, which is 32. That's 8. Bring down the 6. That's 5, which is 80. Bring down the 6. Bring down the 2. That's going to be 3, which is 48, I believe. and what's that, 14, which is going to give us an E here. Once you do that, then you can basically say 16 into 253. That goes once. 16, that's 9. Bring down the 3. 16 goes into that 5 times, which is 80, which is 13, which is D. And the other digit here is F. Hopefully I did that right. I did it in a hurry. I didn't really check. But this is a quick way to do that kind of subtraction. So yeah, so you're going to have this number 65,000 in decimal is equal to FDE8. Okay, so that's pretty straightforward. Now if you take a look at the lab again, there was another number, minus 25,000. I'm just going to put that up there and switch the page and switch over so I don't have to erase this. But if we look at, so the number was minus 25,000. Let's take a look. I'm hoping you're still seeing what I'm saying. Okay, so let's do, instead of 25,000, let's do minus 20,000. Well, how do you do that? Well, if you take a look, and let's take a look at an unsigned short line and a signed short line and see how they're different. Instead of being 0, 0, it's 0, 0, 0, 0, because this is unsigned short. Short is always 16 bits, so this is 7FFF. So this is 0 in decimal, 32767. I just happen to know that, okay? And this is 8000, which is 32768. And this is FFFF, which is 65,535. And what you're going to find from this FF to this one, which is, let me clean that up here, there's also another one down here, which is FFFF, which again is minus 1. So the difference between these two is 65,536, which is 2 to the 16. So the offset between any number here and a number here is this number here. So to figure out how to do this, we first of all say 65,536 minus 20,000. Figure out what this number is, and then divide by 16 3 times. You've got your answer. And for the first one, for the 60,000, let me just switch back here for a second. It's going to say, well, is this number 65,000? Is it signed or unsigned? And explain. Let's take a look over here. 60,000 is somewhere over here, right? So 60,000. Whoops. Let's get my pen out again. Let's do this in a funny color. So this would be 60,000 over here. Now, does it exist in the signed line? No, because 7FFF, which is the most positive number, is 32767. It's bigger than anything. So these numbers here in this range only exist as unsigned. They do not exist as signed. And that would be your explanation there if they asked you that on the thing. So it only exists in the unsigned line, so it only can be unsigned. Now, if I had a number like, I don't know, 20,000, 20,000 exists here, and 20,000 exists here. Therefore, I would say that, it could be signed or unsigned. But if I have a negative, it can only exist signed. And that's the kind of explanation that's here. So let's go back to our lab quickly, because I know I'm losing myself and some of you guys as well and putting you to sleep. I know I'm putting myself to sleep. I hope I don't go comatose on you. But anyway, let's continue on. So that's the explanation. Now, this is bitwise ANDing and ORing, okay? And this one, again, there is a video to show you how to do this. And you have to check through this entire chart to figure out, when I do AB, is this AB in binary? When I take a look at 0F, which is my bold value, is this 0F? Now, when I AND this number with this number, do I get this number? In other words, when I AND this guy with this guy, do I get this? And when I AND this with this, do I get that? And then you say, okay, well, what happens if I take this number and instead of ANDing it, let's OR it? Let's OR it with 0F. Is this the number I get? If I take this number instead of ANDing it, if I exclusive OR it with 0F, is this the number I get? And if I do the ones complement, is this the number I get? And again, you're going to have to check through this entire chart here to see if these numbers make sense. Let's go through some very basic stuff quickly so I can let you guys go. Because as I said, on the EF section, next time we'll be able to do this in a lot more detail. But let me just do this very quickly and switch back to my iPad and show you how to do these bitwise operations. Now, for those people that have done this in PRG, there's a double ampersand. That's not the same because it says if this condition and this condition. So if I take a look at a number like this, let's just see if I get my pencil up here. So let's go black. So there we go. Come on, click. There we go. So if I have a number like 10110110, and I want to say and that, which is just a single ampersand with 11010111, then it's like saying, okay, well, I've got an AND gate sitting here. And what I'm going to do, let me just clean this up. I put it in the wrong place. I do apologize for that. So for adding these two together, we can think of this as inputs to an AND gate. So there's our AND gate there. Hopefully you guys remember how AND gates work. And let's take these as the two inputs and see what our output is going to be. Now, if you remember with an AND function is like this. It's 0x, you get 0. A 1 and an x for an AND gate, you get an x. Because if this is 0, it doesn't matter what this guy is, you're still going to get 0. Anything ANDed with 0 is 0. But if you have a 1 here, if this is a 0, my answer is 0. If this is a 1, my answer is 1. So this is the sort of quick way of looking at this. So when we do this, we can say, well, 0 ANDed with 1. The only time we're going to get 1s is when both are 1. So that's a 1, that's a 1, that's a 1, that's a 1. All the other stuff in here is going to be 0, and there's my result. Okay? So this is what an AND does. Now an OR, I think you should, if we want to do an OR of these two numbers, let's get rid of this and take a look at what ORing is going to look like. OR is a slightly different gate. You should have seen this before, I think, in some of your courses somewhere. So let's do the OR gate. The OR gate basically looks like this, and it's a little more curved like that. And the way the OR gate works is this. If this is a 0 and that's an x, you get an x. If this is a 1 and this is an x, you get a 1. So what it means is that if we do this bit by bit, so if we have a 1, it's going to be 1, 1, 1, 1. The only time you're going to get a 0 is when both are 0. Right? And so that's how you do ORs. Now the one that screws you guys up a lot is the exclusive OR. And we'll take a look. These are, again, videos or short videos to show you how to do this. And the only difference between an OR and exclusive OR is you get this one extra bar. But the way it works is this. For exclusive OR, if this is a 0 and this is an x, and this is a 1 and this is an x, it's a little different. So the way it works is this. I like to think about it as you've got a 1 and a 0 and a 1 and a 1, or a 0 and a 0. So if two women go to a fancy dress ball and this lady's wearing green, this one's wearing red, fashion, perfect, no problem. If this one's doing the opposite, no problem. But they both show up with green dresses, uh-oh. Both show up with red dresses, uh-oh. To be exclusive, you've got to be different. You can't be like the other person. So for instance, if this is 0, 1, my answer is a 0 here and this is a 1, my answer is going to be 0. If I have a 0, 0, my answer is 0. So no matter what I do here, sorry, let me get this right. I screwed that up. Sorry about that. So in this case, whatever you put in here, if I put in a 0, then that's going to give me a 0 out. If I put a 1 here, that's going to give me a 1 out. So this is going to be whatever I put in, I'm going to get out. In this case, though, if I put a 1 in here, that's a 0. I put a 0 in here, that's a 1. So this is going to be x bar. It's going to be the inverse of that. So this is how this works. So let's take a look at what our answer would be up here very quickly. So this is going to be, it's the same, fashion disaster. Fashion success, fashion success, fashion disaster, fashion disaster, fashion disaster. And that is our answer there. The last one I'm going to do, hopefully, so we can get the hell out of here, is if we just take one of these numbers, whoops, one of these numbers and do this thing called tilde. Tilde, which is the 1's complement. So the way it works is if I say this number, that's fine. If I do the tilde of that number, tilde of this, that means the result's going to be the complete opposite, 0, 0, 1, 0, 0, 1. So this is the inverse of that, and hopefully from this, and I've done this in a big hurry, so I do apologize, but there are videos. Let's just go back and take a look at lab one last time to finish this off. So that's what this not X here is doing, right? So AB, is this the complete inverse of AB? So you write AB in binary, is this how it looks here? So if you look here, you got 1, 0, 1, 0, 0, 1, 1, 0. Is that the complete reverse? And I think you can see that it is. So again, you have to check out this entire chart and figure out which ones are not right and circle those and have the entire lab ready for next week, because what you're going to have in your lab, and it showed you this in the thing at the start, it's going to show you this filled in little sections at a time, said, is this right, is that right, is this right, is that right? And you're going to have to decide based on your ability to figure out this entire lab, every bit of it, and it's going to say, okay, and it's going to circle some stuff. It might circle this, it might circle this, it might circle that. Say, is that right? Or maybe I'm circling this and circling that and circling that. Are these the errors, yes or no? But you don't need to submit any work. It's done on a lab quiz. Let's just finish this off very quickly with the addendum so you can see what I'm talking about here. So let's go back to, yeah, this guy here. And let's switch over to another screen here. And let's take a look at your addendum. So in your addendum, everything that's said here, whether you're doing or whatever, I'm on the wrong one here. Let's go back to the DF, or it doesn't matter whether it's DF or DD. So for DD or EE, you're going to have a different screen coming up here slightly, but the addendum is going to be the same. And what you're going to see here is next week on your lab, you're going to have a lab 1 quiz, which is going to be a respondus thing that's randomly generated, and it's going to come up and say, are these the errors? Are these the errors? Are these the errors? Or none of the above are the errors for question 1. Same thing for question 1B, 1C, 1D. It's going to come through all that, and you're going to, if you've figured out and filled in the entire lab 1, lab 1 quiz is going to go like that, and you're going to get 2%. And when you're finished, you better start setting up your MBED account, installing a serial driver, configuring PuTTY, and being ready for the following one, because you can see lab 2 here next week is going to have a quiz based on figuring out a program and so forth. Let me just see if I can switch one last time, see if I can do this, just to show you a thing here. Let's go to content. Is this the one I want to do? So, okay, let's go to here. Is this the one? Nope. 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 Oh, I'm on the wrong screen. Just a minute. Let's go if I can bring up the other screen. No, I don't have it. So let's see if I can get up on one of these screens and then just share it with. Just give me a second here. So this is the thing that you're going to be looking at as I share it with you in a second here. There we go. And let's see if I can share that screen with you. Let's go back here. So, okay, I think this is the one. Yeah, there it is. So what you're going to do is you're going to go to MBED, and MBED has it's os.mbed.com, as you can see up here. And you go to compiler, going to be able to, starting in lab 2, be able to log in and do stuff. But before you log in, you're going to have to do a sign up, and you got to give all this information. And then once you do that, you can go back to the login screen, and you'll be able to then create console applications. You actually don't have to create them. I'll be giving them to you, and all you have to do is import them into the thing. So for the first few programs, you're just going to click on it, and it's going to come right into the compiler, and it's going to have some errors. You're going to have to correct those errors and so on. And this is shown in that video that was right at the start. Let's just finish off with that. If we go back here one last time, sorry about that. I'm flipping around a lot. Oh, here we go. So what you're going to see is something like this. You're going to see, let's just double click on this guy here. And there is a program. Let's just get rid of this. So there's going to be something which you can bring in, which is an error. So for instance, if I go up here, I can click on this, and it's just going to say, okay, here it is. And I can just say import into compiler, and that file is going to be right in your compiler with error, and you're going to have to be able to fix it up. And that's the kind of stuff that's going to make a lot of the programming fairly easy starting next week. Now, I do apologize for going through both periods, but this is such a big piece of stuff that I need you to do. And as I said, for the e-group, you're going to get the first 5 questions. We're going to do that in your lab and so forth, and hopefully get you there. Is there an application? It's basically, you just bring up os.mbed.com. It's a cloud compiler. And the beauty is you can be on one computer and create this stuff. Then you can go to any other computer, laptop, whatever the heck it is, with a web browser, create it, and download it to your Freedom K64, and it will run it. But again, before week 3 or 2 or whatever it is, you have to set up Embed, you have to set PuTTY, you have to do a bunch of stuff so you can get at this point. And this is going to be, let's see if I can go back to here one more time and look at it. And for instance, this one here, let's take a look at this guy. So this one has got, look at that, functions, the stuff you suck at, and function definitions, function whatever. This is the stuff that you're going to be doing, which is a lot like PRG1 and so on was. And so the errors that are going to be in these programs that you have to fix up are probably going to be part of the function prototype or the function definition. So this is going to be a quick way for you to sort of get working on this stuff and try it out on your own microcontroller at home and play with it. So there's a lot of stuff here you can work on, but make sure you get through everything that you need on Lab 1 before next week. Yeah, no kidding. But this is C programming, people. This is the fun stuff. You're going to be able to turn on LEDs. You're going to be able to, hopefully by the end of the semester, set up a something called a dashboard on the web and be able to have your microcontroller through the Ethernet connector connect up to that. So whatever you do on your board, it will update the web page, and stuff you do on the web page can affect what's back on your board, which I think is pretty cool stuff, which is part of Internet of Things or IoT. So this is hopefully going to be a fun course, but the only way you're going to get through this is to work at it. If you have problems, let me know and I'll get you through that. The videos should help, and when those don't help, then contact me and we'll see. Visual Studio, no. Visual Studio is garbage, okay? It only works on PCs. This compiler that you're working on is specific to your Freedom K64. The Freedom K64 is part of the IoT network. Visual Studio cannot handle this stuff, okay? And that's why you've got something here called include embed.h, right? There's nothing else that does embed.h. Anyway, that's it for me for today, because I want to give you at least 10 minutes at the end, that if there's any questions, you can sort of post them in the room. I'll try and deal with that at the end. So I'm just going to shut off the video right now so that you don't have something that's going to be like, you know, Lord of the Rings extended version or something to watch. So if there's any questions, stick around and ask. If not, I'll see you guys in your next